Welcome to One Chemistry. Always try to do your best. Now, let us see about how to find R&S configuration. We are going to see complete course. We will see 9 different unique chiral compounds, that is allenes, pyranes, biphenyls, ANSA compound, cyclopanes, binaphthyl, cycloactine and adamantane. And we will see it as bonus helicenes, the spiral chirality. So we will see step by step nature of chirality and all the influencing facts. Stay tuned. What is inside this video? Inside this video we will see what is chirality first, then we will see the types of chirality, later we will see how we can find R&S configuration. The new name is P&M configuration, and we will discuss the two important things, pilot atom and viewing angle. So we are going to see complete course on R&S configuration. What are the compounds we will see? Allenes, cyclopanes, ANSA compound, biphenyl, binaphthyl, pyranes, helicene, cycloactine and adamantane. The video will be sequential, you can go wherever you are interested. First, let us see what is chirality. Chirality is the interesting thing. You might experience without knowing the chirality. You ever wonder why left shoe only fit for left leg, not in the right leg? That is because shoes are different in the 3D space. That's why you cannot fit reverse. So the shoes are 3-dimensionally different. That is called chirality. Technically, the 3 dimension is called stereo. This kind of structure is technically called stereochemistry. In chemistry, the compounds also can be chiral. It divided into 4 types: 0 dimension, 1 dimension, 2 dimension and 3 dimension. 0 dimension everybody knows, it's a chiral center, which is normally the tetrahedral carbon attached with 4 different atoms. Then the chiral axis, the chirality created by the chiral axis. Then the chiral plane, it created by the twisting of the structure. Then the 3-dimensional chirality, which is chiral helices, which is created from spiraling of the atoms. 4 different kind of chirality. We will see all the possible structures. At first we will see allene. We are going to see how we can find R&S configuration step by step. You should know the allene first. The allene is the cumulative diene compound, meaning the double bonds are continuously placed together. But how they really look, if you have to see, mean 2 perpendicular planes are there. So you have to also know how you can draw in 3D. If you draw in 3D, one thing on the plane, another thing is against you. That is hydrogen towards you, chlorine behind you. So you should know what is allene, how they really look, how can draw in the 3D paper. Technically, you have to imagine the molecule in the 3D space. Then let us see the important thing, how the allene is chiral. Allene is chiral due to its chiral axis because it creates the chirality by its unique nature. So we don't need any 4 different attachments. Here I shown the allene, but if you imagine technically it is like tetrahedral carbon, but it's elongated or stretched tetrahedron. So simple way if you look at it, it's like simple tetrahedral carbon. Since it's created from the chiral axis, you don't need 4 different atoms. So stretching creates asymmetry, in turn it creates the chirality. So the chirality is called axial chirality, the elongation in particular direction. So the concept here is allene is chiral without chiral carbon. The allene chirality created by the chiral axis, which in turn are optically active. Before we get into R&S configuration, we have to check the chirality. If it is chiral mean we will see R&S. If it is not chiral mean no need to see R&S because it is meaningless. So we will see different allenes with different substitution. Let us see the all different compound. Let us see the A first. A is not chiral because it has mirror plane of symmetry. Even though 2 planes are perpendicular, it reflects each other, so it is not chiral. The same thing happened with 2 substituted chlorine, which is B. It is also not chiral, so we cannot say R and S. If you look at the C, it is not chiral because of the one more double bond. We will see these facts little bit later. Then we see D, which have chiral axis. We can say R and S. Alene attached with spirene kind of architecture, that is also chiral. We can say R and S. Then with 4 different atoms, definitely it is chiral. So you have to know whether the compound is chiral or not by your understanding and by imagining the molecule. Then we will see little bit extra on chirality. The nature of double bond is even number of double bonds create the chirality. Odd number creates not chiral. We have to see these 4 compounds. First one has 1 double bond, second is 2, third compound has 3, fourth one has 4. If you look at all 4, the even one is chiral, the odd one is not chiral, because the perpendicularity only achieved by even number of bonds, not by odd number of bonds. So even number of bonds are chiral. Then we will see the important factor, viewing side. Viewing side is the side where you are looking at the molecule. Here I shown the viewing side. Suppose you are seeing from there, mean chlorine is right hand side of you, hydrogen is left hand side of you, and bromine is above your head, CH3 is below your head. So if you imagine the molecule, this is the fact. How we can draw it? We have to draw from thick line and thin line. Thick line is near to you, thin line is behind to you. Here thick line is left and right because you are seeing the molecule in the 3D space. So thick line is hydrogen and chlorine and thin line is bromine and CH3. So you have to master the viewing angle to find R and S configuration. Then we will see step by step procedure for R and S configuration. The first step is assigning the viewing side. You have to choose where you are seeing the molecule. Here I shown viewing side A, B, C, D. A, B is near to you, C, D is behind you. Then we have to get the priority of front side then back side. Then you have to give the numbers based on CIP rule. First priority is front side, then only CIP rule. So if you look at the orientation after the numbering, clockwise mean it is R, anti-clockwise mean it is S. For R, new name is P, for S, new name is M. Let us look at this alene molecule ABCD. If you look at the A, chlorine, B, hydrogen, C, chlorine, D, hydrogen. Here AB is near to you, which is chlorine right hand side of you, hydrogen left hand side of you. Then hydrogen is above you, which is D, and chlorine is below you, which is C. Here thick line gets higher priority than thin line, so we do the numbering 1, 2, 3. If you do 1, 2, 3, 4, it is anti-clockwise, it is S direction. Here the important fact you should memorize is front side hydrogen get even higher priority than chlorine. Then the important fact, changing the viewing angle don't change the results. Many people confuse what I choose, other side of the viewing angle. The answer will be same, but you have to master left hand side and right hand side. Here the first one is we are seeing the molecule from above and below side. Second one you are seeing from planar side. Here looking at the opposite side mean you are getting the same configuration because chlorine in the right side become left hand side. The configuration won't change. Both have anti-clockwise S direction. So the changing the viewing angle don't change the results. Then I given the some example to practice yourself. Viewing angle I fixed as it constant. So 1 and 2 side is the viewing angle. I write the priority according to that. So if you do that, first one is R, second one is also R, third one is S. The double bond gets higher priority than single. That's why it is anti-clockwise. Then the fourth one, which is also deuterium. Atomic mass get higher priority than atomic number here. Since the atomic numbers are same, we have to look at atomic mass. So deuterium gets higher than hydrogen. So it is clockwise, it is R. Let us summarize what we see. First you have to check the chirality before finding R and S. Here the alene is chiral due to its chiral axis. So it's a very important fact. Then check the chirality before finding R and S. If it is a clockwise direction it is R. If it is anti-clockwise direction it is S. New name is P and M. Old name is R and S. Then the chirality all are hydrogen mean easy, not chiral. Then if it is two substituent on same carbon, that is also not chiral. If it is a different attachment, definitely it is chiral. Then odd number of double bonds also not chiral. Then the spirane attachment can create chirality like spirane. These are all the facts you should know about allene. Now let us look at the cyclopene. We are going to see R and S configuration of it. The cyclopenes are unique compound. They have chirality due to its substitution because the chiral plane creates the chirality, not the attachment of atom. Here I am showing substituted and not substituted cyclopene. First one is you are with hydrogen, second one is you are with chlorine there. The first one is not chiral because of the mirror image. Second one is chiral because there is no mirror image. Here the plane is chiral, that's why it's create the chirality, which is called plane chirality, which makes it optically active. So without chiral carbon, chirality is possible. Here plane chirality create the chiral activity. Then before we get into R and S configuration, you should check the chirality. The chiral mean, as we seen earlier, we can find R and S. Not chiral mean we cannot say R and S because saying R and S is meaningless. The first one definitely there is a mirror image because all are hydrogen. Second one also having mirror image because both are bromine there. It bisects the plane, which is half is above the plane, half is below the plane, which is your computer screen. So we cannot say R and S. If you look at the third one, it has mirror plane which bisects the both rings. So what really happens is it having mirror image, it is not chiral. So only the single substitution can create the chirality because it does not possess any mirror plane of symmetry. So careful and check the chirality. Then before we get into really what is R and S configuration, we have to see pilot atom. Everybody know helicopter. The pilot means who is sitting on the front side of the craft. If you look at our molecule, the first atom above the plane is called pilot. It's like helicopter, it is a pilot there. Since the substitution create the chirality, you have to choose the pilot near to the substituent, not away from the substituent. Here one is pilot, one is not pilot because one is near to substituent, one is away from substituent. So you have to master the identification of pilot atom. Now let us see how we can identify R and S. First you fix the pilot atom which is near to our substituent. Then atom near the pilot get higher priority. Then you have to write continuously the numbers there. So if you write it clockwise mean it is R, anti-clockwise mean it is S. For clockwise new name is P, anti-clockwise new name is M. Here the pilot position is crucial. Simple way, always keep the pilot upside. The pilot below mean you will get the answer reverse. Here the important point I want to say here is don't confuse with CIP rule. Here is entirely different. Priority of pilot is higher than the chlorine. So you should understand that. Second and important thing, bring the pilot atom upside. If you are a master, you can reverse the configuration. I would suggest that you have to rotate the molecule to find R and S. Here the pilot atom is below. So you have to rotate 180 degree to get above. Then you have to write R and S configuration. Or simply you can say pilot is below mean the configuration will be reversed. But most people will confuse. So I would say always keep the pilot atom above. Then the compound can have many chiral planes, so you should know that. Here I given a compound with two different substituents, bromine and chlorine, so you might confuse where is the pilot there. So you have to choose chlorine pilot as well as the bromine pilot. Then you have to find the priority. So bromine side mean 1, 2, 3, 4 clockwise. Chlorine side mean again also clockwise. The configuration is reversed, so it is yes there. Like any other chiral compound, cyclopenes can have many chiral planes. Then we will see some common confusion. Here the first compound and second compound you might see the chirality in different point of view. The first one you see the chirality created from chiral center, so normal CIP rules apply. So it is anti-clockwise S direction. Here don't confuse with our cyclopane rules. Then the second compound, you just see the chirality created from the chiral plane. So you have to choose the pilot and get the priority. So don't confuse with normal chirality and plane chirality. Let us summarize some points on cyclopane. For clockwise, the old name is R. Anti-clockwise, old name is S. For IUPAC, you have to write P and M. Before getting to any R and S configuration, you should know origin of chirality as well as the plane of symmetry inside. Then the important thing you should know here is pilot even get higher priority than atomic number. It won't obey normal CIP rules. Then let us see our third compound, which is Hansa compound. We are going to see R and S configuration of it step by step and easy way. Let us know the Hansa compound first. Hansa compound is the benzene compound which has pair attachment and long cyclic ring mostly near to the 6. Here we are seeing only standard concepts. The methyl ring size is 6 there. Here, if you don't have any substitution, it is achiral compound. But if you create the chlorine, it creates chirality, which is plane chirality, which makes it optically active. Here, chirality created by the benzene plane, or you can say the new plane. That's why it is called plane chirality. So you should know the fact that the Hansa compounds are benzene derivative. It has plane chirality, which is two-dimensional chirality. Then we will see the common variables of Hansa compound. Here the Hansa compounds are like oxygen substituted with chlorine or oxygen substituted with chlorine and bromine or just the methyl derivatives. Here more number of methyl instead of oxygen atom. So these are the standard thing. Either you can change in the substitution or in the ring heteroatom. It can be either carbon or oxygen. Here also the concept of pilot atom comes. As we seen earlier, pilot is the front side of the craft. Here also the first atom above the plane. Here oxygen and benzene in the plane. The first atom above the plane is pilot. The atom near to the chlorine technically called pilot, not others. So the same thing apply like cyclopane. How we can find R and S? Same thing like cyclopane. First step is finding the pilot atom. The atom near the pilot get higher priority. So continuously we write the numbers there. Clockwise mean it is R, anti-clockwise mean it is S. New name is P and M. Here the pilot position is crucial. Simple way, always keep the pilot position above the plane. Here I given the compound. Pilot is near to the methyl, which is near to the chlorine. If you write it, you have clockwise configuration 1, 2, 3, 4, which is R configuration, or you can say P configuration. The important thing you have to know here is don't confuse with CIP rules. That is, chlorine priority is higher than oxygen, but here chlorine gets 4, oxygen gets first here. Then I want to emphasize the point again. The pilot always have higher priority. The first one you just see, oxygen get higher priority than chlorine. Since oxygen near to the pilot always get higher priority. Same with methyl group, again it gets higher priority than chlorine. So you have to know the fact that irrespective of atoms or atomic number, the atom near to the pilot gets higher priority. Then the common confusion is position of the pilot. Always bring the pilot above the plane. If it is reversed, the answer also will be reversed. For advanced level it is okay. For learner I would suggest always bring the pilot atom above. If it given below, you have to write it with above. But careful with substitution. Substitution will reverse. First you see chlorine is below, chlorine will come above. Then if you do R and S configuration, it will be easy. It follow our standard rules. So careful, bring the pilot atom always upside, particularly for beginners. Second important thing is the molecule can have two chiral plane or technically two chiral center. Like our diastereomer, it can have many. Here I shown the compound with chlorine substitution and bromine substitution. Two kind of arrangement is there, so two name will come. So both will have RR configuration. Like our diastereomer, you have to write RR. So one is from chlorine pilot, one is from bromine pilot. So the fact here is the molecule can have many chiral planes. Then the important thing I want to know, before you get into R and S, you have to check the chirality. The normal hydrogen thing never gets chirality because of the mirror plane, it won't be chiral. If you look at the bromine in both the ortho position, it is not chiral because of its position on the symmetrical way. So it is not chiral, we cannot say R and S. So careful with the chirality before getting to R and S configuration. Let us summarize the important facts here. The common fact is clockwise and anti-clockwise, which is R and S, or new way P and M. Then you have to check the chirality. If it is a symmetrical one, it won't be chiral, we cannot say R and S. Then you have to always focus on the substituent which near to the pilot. Then the compound can have many chiral planes. The important fact you have to learn here is the pilot always get higher priority than any atomic number. Let us get into our fourth compound, which is biphenyl. As usual, we are going to see R and S configuration of it. First, let us know biphenyl. The biphenyl is the compound. It's like two benzene ring attached with single bond, but the ortho positions are occupied with bulky atoms. The normal ones are methyl and halogen. So what is really the matter is both rings are perpendicular to each other. Like twisted ring, both are perpendicular. So you should know how to represent those rings in 3D way. But in paper you have to draw in wedge and dot structure, the molecule above the plane and below the plane. So you have to master the molecule and you have to imagine in the 3D. Let us see how the biphenyl is chiral. Here just simply see the biphenyl compound. Technically it is like tetrahedral center. 4 different atoms are attached with it. So you can imagine that also, but really it is a chiral axis. The axis is chiral, it don't have any mirror image. So two perpendicular planes create the chiral axis. So the fact here is without chiral carbon, the chirality is possible. Then the biphenyl is chiral due to its chiral axis. Before getting to our R and S, we have to check the chirality. Be careful with that. If the compound is chiral only, we go for R and S. If it is not chiral, there is no need to say R and S. If you look at the A, it has mirror plane which bisect the benzene ring and reflect the hydrogen. If you look at the B, the same thing. The plane goes through CH3 and hydrogen, it reflects the hydrogen. If you look at the C, again 2 methyl group reflects, you will get the plane of symmetry. If you look at the D, it is not chiral because of the fused 2 carbon system, the molecule is perfectly planar. E, F and G are chiral. E and F are our identical samples. The chiral axis create the chirality. If you look at the G, it's a normal chiral carbon. So don't confuse with chiral carbon and the chiral axis. Then the important fact, like any other, viewing side, which is a deciding factor. Viewing side is the angle you see the biphenyl molecule. So you have to choose which side you are seeing the molecule. Here you are seeing the molecule from chlorine and hydrogen side. The chlorine is right side of you, hydrogen is left side of you, bromine is above you, CH3 is below you. You can represent the same way. Thick line is your viewing side, which is front side. Thin line is back side. So we have right, top, bottom, right, left. That's how you have to represent the molecule in 3D. So you have to imagine the molecule in 3D and you have to choose the viewing side. It's a very important thing because it decides everything. Then how we can find R and S? Same thing like pilot atom. Here you just choose the viewing side. Here front side gets higher priority than back side. Later you apply the CIP rule. By CIP rule you have to go by the priority. Then you have to give the number and find the orientation. If it is clockwise it is R, anti-clockwise yes. New name is P and M. Here the important fact you have to know here is changing the viewing side won't change the results. Let us look at the molecule. You are seeing the OH and H side. OH is right side of you, hydrogen is left side of you, chlorine is above you, bromine is below you. So front side gets higher priority 1 and 2. 1 is oxygen because of atomic number. In the back side, bromine gets higher atomic number, it gets the priority. So if you find it, it will be anti-clockwise. Here the important fact you have to know here is the front side hydrogen even get higher priority than back side chlorine and bromine. Then we will see the common confusion. What if I choose the various viewing angle? The answer won't change because we are just viewing the molecule in different way. Here the first example you are seeing from bromine and chlorine side. Second example you are seeing from hydrogen and OH side. So only thicker and thin line vary and right side and left side vary. Hydrogen and OH don't vary. So if you look at it, answer will be same. Both will be anti-clockwise. So changing the viewing angle don't change the results. Then I given the common example to practice yourself. Here the first one is with nitro and acid. Here front side gets higher priority, then nitrogen gets even higher than COOH. So if you do it, it's anti-clockwise. The second one, always you go with the higher priority. So nitrogen attached to get higher priority than hydrogen. If you do it, it will be clockwise. The third one is easy. Iodine gets higher priority than bromine. So if you do it, clockwise direction R. Fourth one, you have acid, chloride and acid. The substitution of chlorine gets higher priority than acid. So you have clockwise R. So you have to practice yourself, master the configuration. Let us summarize the points here. First you have to check the chirality before finding R and S. Here the biphenyl gets chirality due to the chiral axis. The chiral axis create the chirality. Before we get into R and S configuration, you should check the chirality. If you find the clockwise orientation, it is R. If it is anti-clockwise, it is S. The new name is P and M. Then very important thing, you have to master the viewing angle and imagine the molecule in 3D. Here I given the some summarizing example, which is similar atom get planarity, it is not chiral. Different one obviously get chirality. Then you go by the CIP rule. After choosing the viewing angle, then you get the configuration. The very important thing you should know here is changing the viewing angle won't change the results. Let us get into our fifth compound, binaphthyl system. We will see how we can find R and S configuration. Let us know the binaphthyl first. Binaphthyl systems are two naphthalene systems attached through single bond. Most of the time it has ortho substitution with some substitution. Here it is OH. How it's really look is both are perpendicular to each other to avoid the steric effect. How we can draw in 3D? You have to draw above and below kind of architecture. It will be like spring there, like spiraling system. So the solid wedge represents the structures above the plane. So due to the steric effect, it has two perpendicular kind of architecture. We have to look into the fact that how binaphthyl is chiral there. Because the chiral axis creates the chirality, makes it optically active. Here I given the binaphthyl, but if you think it simply, it's a kind of tetrahedral carbon. You just see the highlighted carbon where you have 4 different attachments, so it behaves like chiral center. So two perpendicular planes create the chiral axis, which in turn create the chirality. So the concept here is without chiral carbon, the chirality is possible. Binaphthyl chirality created from the chiral axis. Then the common fact, we have to check the chirality before we get into R and S. Normally the attachment which is in the ortho position should be bulky. If it is not bulky, we cannot say achiral, but we have to say least chiral. The first one we see both are hydrogen, we won't say R and S because of the spinning rotation. Second also it has one hydrogen and two bulky group, but still we won't say it because of the rotation. The fourth and last one is phenyl group attached, which is phosphine, which is very bulky. Definitely it is chiral because of its perpendicular arrangement due to steric effect. So we can say R and S. So the concept here is bulkiness decide the chirality, which prevent the rotation. Then the important thing we should know, like viewing angle, here viewing side is important, where you are seeing the molecule. Here suppose you are seeing the molecule from bottom, mean A is above you because it's a solid line, B is below you, and C is right side of you, D is left side of you. Same thing we represent like previous, you have to draw in 2D, thick line and thin line. Thick line is near to you, thin line is back side of you. So you have to draw the number based on thick and thin. So you have to master the viewing angle. Let us see how we can find R and S. You have to imagine the molecule in 3D first. First decide the viewing angle, where you have front atoms get higher priority than backside. Then you have to go for CAP rule. CAP rule based on its atomic number. Here I am showing A and B are near to you. A is above to you, B is below to you. So above and below. Then C and D, which is backside of you, which will have less preference. So if you draw the numbering, you will have clockwise orientation. So if it is clockwise, we can say R. If it is anti-clockwise, we can say S. New name is as usual P and M. Here also the important fact, changing the viewing angle won't change the result. The front hydrogen even get higher priority than backside Voges groups. So the priority comes to the front groups. Here we see the fact detailing, changing the viewing angle don't change the result. The same molecule is given, you are seeing from two different angles. The above and below won't change, you are just looking it up the molecule, so you have the similar answer. Here you have complete rotation of the molecule, so everything will change. Right becomes left, left becomes right. Since all are changed, the priority and the orientation will be same there. So both will have clockwise and the orientation is R. So change the viewing angle won't change the results. Nowadays easy trick is available for R and S, but I won't recommend it because sometimes it creates confusion if there is stereochemistry is not specified. For this, what you have to do is draw the curves towards the atoms above the plane. I am drawing above the plane to above the plane curve. If you have reverse S-shape configuration, it is R. If you have S-shape configuration, it is S. You can draw a curve from 1 and 2, answer will be same. So draw the curves from above the plane to above the plane. If you have reverse S, it is R configuration. If you have S, it is the S configuration. Then I given some example to practice yourself. So practice yourself with the given answer. Here COH is the first one. If you arrange the priority, you have clockwise R. All four compounds have viewing angle same. The viewing from the below. The first one will have R, second one will be anti-clockwise, which is S, third one will be R, fourth one will be anti-clockwise. Let us summarize what we seen. The chiral axis in the binaphthyl create the chirality. Before getting to R and S, you should know whether it is chiral or not. If it is chiral, clockwise mean it is R, anti-clockwise mean it is S, or you can say P and M. Then you have to master the viewing angle. Then S shape mean it is S, reverse shape mean it is R. The important fact you should know here is changing the viewing angle won't change the results. Then we will see our sixth compound, which is styrene. We are going to see how we can find R and S configuration of it. First, let us know the styrene. Styrene is the kind of twisted structure where you have substitution in the second position where the fused carbon. So the molecule is technically tetrahedral at middle. How they really look is two perpendicular planes are there. you have to draw one ring in plane, another ring above the hydrogen and below the methyl. So you should know how to draw the molecule in 3D, and you should know both are perpendicular planes. Then how the spirane is chiral? Here I given the simple example. The chiral center or chiral plane create the chirality, which in turn gives the optical activity. Here you see I given the twisted plane. If you imagine, it will be a perfect tetrahedral structure. So that's why it behaves chiral there. But technically it comes from the chiral axis. So the fact here is without chiral carbon, chirality is possible. Spiranes can have the chiral axis and chiral center both at the same time. Here also you careful with your chirality, because chirality is the deciding factor for R and S. Here the 4 examples A, B, C, D all are not chiral. A is all are hydrogen, you have perfect mirror plane. B is also having mirror plane through CH3. C is also having mirror plane through fluorine. Then D is also having the mirror plane because the molecule itself plane are there. Only E, F, G, H, I are chiral, and we can say R and S. Here E, F are similar. Only the chlorine positions are different, whereas cis are trans kind of chlorine architecture. Since the plane is perpendicular, we can say R and S. If you look at the G, it's a kind of attachment with the terminal. Still it is chiral. Still it creates the chiral axis. You have different ring size, 5 member and 6 member. Still the chirality rule applies. The I1 is easy, normal chiral carbon. You can say R and S. So you have to know whether the compound is chiral or not. We have to see little extra on chirality because the ring numbers. Here the odd number of rings create the planarity, it makes it not chiral. Even number of rings create the non-planarity, which creates a chiral. You just see simple cyclobutane, it is not chiral since it is planar there. But if you have 2 rings, it is chiral because of perpendicular arrangement. If you look at the 3 double bonded structure, the terminal become planar, that's why it's optically inactive. That's why it is not chiral. So check with the ring numbers before finding the chirality. Then the same concept viewing side. Here also is like binaphthalate and biphenyl. You have to master the viewing side. You have to take the front side and back side view. Front side you have right, left and right. Back side is thin line, which will be top and bottom. Here left and right will be chlorine and hydrogen, top and bottom will be bromine and methyl. So you will represent it as thick line and thin line. So you have to imagine the molecule in 3D and master the viewing side. Then we will see how we can find R and S. The same thing like previous. First you have to decide the viewing angle, then give the priority of front side to the back side. Then you have to go for CAP rule. CAP rule, the atomic number gets the priority, higher will be higher the priority. Then you find the orientation. If it is clockwise mean it is R, anti-clockwise mean it is yes. The change in the viewing angle never change the results. Here let us see by the example. You are seeing from hydrogen and OH side. OH is right side of you, hydrogen is left side of you, chlorine is above you, bromine is below you. So if you find the orientation, you have anti-clockwise, it is yes. Here the important fact you have to know here is front side hydrogen even get higher priority than back side chlorine and bromine. Then let us emphasize the fact that changing the viewing angle won't change the results. Here I given the same molecule from different viewing angle. Only your right and left position will change, top and bottom won't change. Since it is in the plane of the paper, it won't change. So the answer will be same, both will be anti-clockwise. Only the viewing side changes mean the atom which is right and left side will change. In turn it will get the same results. So changing the viewing angle don't change the results. Here I given some representative example to practice yourself. The first one, all are having viewing angle same, which is 1 and 2 side. So you have to represent as thick line. So go with the CAP rule and the front side priority to back side priority. The first compound with acid and chlorine, it has configuration of R. Second one with ketone. Ketone have higher priority than carbon, so it has configuration of R. Second one is terminal atoms, so it will also follow the same rule, so it will be anti-clockwise. Third one will be multiple ring system, still the result will be same, it is anti-clockwise. So you have to master the R and S configuration by practicing it. Let us summarize what we seen. The compound, the spirane is chiral due to its chiral axis. Before you get into R and S, you have to check the chirality. If you find the orientation clockwise mean it is R, anti-clockwise mean it is S. The new names are P and M. Then you have to master the viewing angle and you should imagine the molecule in 3D. Here I given the representative example. You have to summarize it by understanding. So you have to understand it. Here I given 3 different examples for your complete understanding. First one is simple spirane. Second one is with terminal atoms. Third one is with double bond and alternative cyclic system. Then we will see our 7th compound, which is helicins there. We are going to see R and S configuration of it. Modern time it is being called as P and M system. So R and S and P and M. Let us know the helicins first. Helicins are continuous benzene attached system. You might imagine like DNA and RNA. You may imagine it like spiral system. You can simply imagine like spring continuously revolving around an axis. This is optically active and chiral, can have an enantiomer. So the helicins are chiral due to its spiral nature. How you can find P and M? Normally you are going from above the plane to above the plane. So you got to choose the priority. Top atoms you have to give 1, bottom atoms you have to give 2. So if you draw the arrangement, it is clockwise mean it is P, anti-clockwise mean it is M. Trick is spam. Clockwise mean it is P, anti-clockwise mean it is M. Here I given the example, solid wedge is above the plane which is first, the dotted line is below the one which is second. So if you go from there it is clockwise, it is plus direction, it is P. Here like R and S configuration, we have P and M configuration. Since we don't have 4 different atoms, this kind of terminality comes in the picture. Here I given some example to practice yourself. These are the known example. The first one is P structure. You are going from above to below. Second one is anti-clockwise. You are going from above to below. Third one also going from above to below leads to clockwise direction. Here the third one is important because side chain also chiral because of the chiral carbon. So the compound can have both spiral center as well as chiral center. Then let us see our 8th compound, which is adamantane. We are going to see how we can find R and S configuration of it. First, let us know the adamantane. Adamantane is a kind of 4-fused cyclohexyl ring system. All are in the chair form. If you look at it, it has 2 tetrahedral centers, blue dots and the red dots. If you draw it separately, it has 2 tetrahedral centers inside. So definitely it's behave like tetrahedral carbon. So adamantane can have 2 tetrahedral centers inside. How the adamantane is chiral? It's very interesting. It can have chiral center as well as the chiral axis. If the attachment with the perfect tetrahedral, it has chiral center. If the attachment at the cross terminal, it will be chiral axis. You can consider it like allene there because it creates perfect allene kind of architecture. So the adamantane can have chiral center as well as chiral axis. So the concept here is without chiral carbon, chirality is possible. Adamantane can have both chiral center as well as chiral axis. So as usual, we have to check the chirality before we get into R&S. If the compound having all hydrogen, it is not chiral. It has many plane of symmetry. Difficult to represent in our paper. Very difficult to draw that. Second one also terminal system which have hydrogen mean it is not chiral. Like our alene, both are same mean it is not chiral. The chiral center mean all should be different. Chiral axis mean at least both atoms have different property. At least single carbon has two different attachments. So you have to master the chirality here. Naming adamantane with chiral center is very easy because you have to go by 1, 2, 3, 4. You have to follow normal tetrahedral carbon. First you have to draw the substitution separately, then apply the CAP rule. Clockwise mean it is R, anti-clockwise mean it is S. Very straightforward. But the important thing is 4 different attachments should be inside. Then adamantane with chiral axis there. How the adamantane is chiral mean? Here adamantane chirality created from the chiral axis. So you have to follow the alene architecture. You have to choose the viewing side. Front side gets higher priority than back side. Then apply the CAP rule. If you find it, you have clockwise mean it is R, anti-clockwise mean it is S. Here I given the example. You are seeing from the chlorine and COH which is AB side. Then if you see chlorine at your right side, COH is at left side. So if you do COH above, chlorine below. So if you find it, it will be anti-clockwise, it is S direction. So adamantane with chiral axis behave like alene system. Let us summarize the points we see. First you have to check the chirality before finding R and S. Clockwise direction mean it is R, anti-clockwise mean it is S. Then chiral center and chiral axis in adamantane system. Chiral center mean you have to follow CAP rule. Chiral axis mean you have to follow the alene method. Then we will see our last compound, cycloactine. We are going to see how we can find R and S configuration of it. First let us know the cycloactine. It's a continuous cyclic structure with the double bond, which is only one double bond. But our interest is only trans one. It has chirality. How it really look? It will look like twisted architecture. So two perpendicular planes like kind of spiral structure. So trans is our sole interest here. Since we will avoid, trans is our sole interest. How you draw in 3D? Always draw in 3D with the double bond in the planar form, which is horizontal form. It will be easy for our configuration. So always practice the double bond in the horizontal way. How the cycloactine is chiral? Cycloactine is chiral like spirin. Since the twisting created similar like two perpendicular plane, so you have to know front side and back side of it. Front side is thick line, back side is dotted line. Practically it will be like two perpendicular plane opposite to each other, which create the chiral plane there. Since it creates the chirality from the plane, 4 different attachments are not required. So the chirality created by the chiral plane, which in turn create the optical activity. Here the concept here is without the chiral carbon, chirality is possible. Cycloactine chirality is created from the chiral plane. Before we get into that, we should know the pilot atom. Like our cyclopane, this pilot atom also same. Like helicopter you have pilot, here also you have the pilot. But the important thing is you have to draw the double bond in the planar form, which is horizontal form. Then the atom above that plane it is called pilot. The below one is not pilot, above one is pilot there. The pilot atom is the one which is out of the plane from the double bonded system. So carefully choose the pilot. How we can find R and S? Same like our cyclopane. First step is pick the pilot. Here priority of pilot is front side then back side. So front side pilot you have to choose. Draw the number around the pilot atom. Here 1, 2, 3, the pilot atom, the first atom out of the double bond. Then you have to draw 1, 2, 3. Clockwise mean it is R, anti-clockwise mean it is S. Since all 4 atoms are not different, we have to give the new terminology P and M, which we already seen. Here I given the representative example. Pilot atom is chosen and 1, 2, 3. The above gets priority, so 1, 2, 3 create the anti-clockwise direction. It is S or M. Here the important thing you should know here is don't confuse with CIP rules. The pilot is always getting higher priority. Then I have to warn you, double bond should be horizontal. Here I given the 3 ways of representing same compound. First one is twisted with double bond in diagonal, second one also diagonal, third one is with linear horizontal form. First two is very difficult to predict the pilot atom since it is not planar. So you have to position double bond correctly to identify the pilot. If double bonds are not horizontal, rotate and get the horizontal. So double bond should be horizontal. Let us summarize the points we seen. The cyclooctane is chiral due to the chiral plane. At first you have to check the double bond horizontal or not, then find the pilot. If the configuration is clockwise mean it is R, if it is anti-clockwise mean it is S. If the orientation is clockwise mean it is R, anti-clockwise mean it is S. The mirror image always have opposite configuration, which is like any other tetrahedral carbon. That's all from this video. I hope it was useful. Thanks for watching. If you have any suggestion, comment below.